This video will continue homework number 8, and we'll the homework problems that were assigned for homework number 8 from the textbook. And then numbers 7 and 9. Numbers 1 and 5 both gave us discs. Number 9 gives us a washer, or in other words, it's a donut shape, a ring, you could call it. With let me go back to problem number 5. When we looked at the cross section, you got an actual disc. It doesn't have a hole in it, and the radius was 2 square root of y. So we could put that 2 square root of y in for radius and integrate from y equals 0 to y equals 9, and do that integration of the area with respect to y over dy. But what we're going to do a little bit differently with example 7 and example a disc, or in other words, the cross section is going to have a hole here. We have the police officer Lego guy here to help us with this problem. We're going to follow the similar process that we used for a disc. So we start by sketching the three-dimensional solid. We get the section, the region that's enclosed by the two graphs. We've got the red 5 minus x squared above and the blue 1/4 of x squared below. So two parabolas intersecting. And we that around the x-axis. So when it spins on the x-axis, we'd get a solid that from the outside it would kind of look like this. And you can see the pink cross section inside here, or I don't know if this red one maybe makes more sense to you, but we get the cross section that's shaped like a donut or a washer or a ring. First step was to sketch the three-dimensional solid and look at the disc or washer, in this case washer. And now we need to find the area of this washer with respect to, in this case, with respect to x. So to get the area of a ring or a washer, we're going to need to tell which of the radii are the outer ring, the outer circle, and which one is the inner circle. So you can see here from the graph that the outer circle is going to be this 5 minus x squared, the red function, and the inner radius is going to be the 1/4 x squared, the blue circle. So when we find the total area, it's going to be pi times radius squared, pi times squared, minus the little circle, pi times 1/4 x squared. We could simplify this calculation by factoring out the pi and saying that the area is going to be pi times 5 minus x squared minus 1/4 x squared. So we get 25 minus 10x squared plus 10x to the 4th minus 1/4 squared is 1/16. X squared is x to the 4th. So to the fourth step is now to find the volume with integration. So the volume with respect to x equals -2 to x equals 2. We found that, I didn't show this earlier, but we found this by getting these two intersection points. And we see that the intersection is x equals -2 and x equals 2. So we're going to integrate from x the area with respect to x over dx. This is another one of those problems from -2 to 2 is the same as integrating from 0 to 2 and doubling. So we're going to take that shortcut and do 2 times the integration from 0 to 2 of the area with respect to x over dx. So that's 2 pi, integrate from x equals 0 to x equals 2, this area, 25 minus 10x squared plus 15/16 x to the 4th dx. And when we integrate that and substitute in a 2 for x, we get 176 pi over 3. So this should help you as you go on to number 7 from the textbook. It's very similar to this number 8. And then this last example, number 9, is going to be another washer example, or a ring. So once again, we're going to graph the two functions, find their intersection, and we get these intersections 0, 0, and 4, 2. So when we integrate, we've got y equals 0. We're going to integrate from y equals 0 up to y equals 4. And that cross section, if we cut a little solid, so like this green circle here, which turns into a washer, because we're going to have the blue function, the 2y, as the outer radius, y squared as the little radius, or the inner radius. So to find the area of this washer, we're going to have 2 squared y squared minus y squared squared, which simplifies to 4y squared minus y to the 4th, all times pi. That's going to give us the area of this donut, or ring, or washer. Ring, cross section of this solid. Remember, what we're trying to do is find the volume of the solid, and since it's hollow in the middle, we're getting a ring. The volume is going to integrate from y equals 0 to y equals 4 of the area with respect to y over dy, and compare your answer to the answer that's in the back of the book.